fault tolerance versus availability. So in fault tolerance, we can think of it as trying to get into a zero downtime. Can we think of a system outside of computers and programming that has fault tolerance? The most obvious answer is yes, and that it's airplanes, commercial airplanes that people fly on. So everything there is fault tolerant when there is an error, hopefully, right? This is what we hope. So when there is an error, a fault on an engine, then we hope that the other engine can do whatever the system needs to do, which is to fly and bring people safely into the target airport. So this is fault tolerant. Basically, we are trying in fault tolerance versus availability, which we'll discuss. So in fault tolerant, we are trying to reach into zero downtime, right? We don't want a downtime of the airplane. We cannot afford it. But on a car, we can afford a downtime. If we have an issue with the car and it stops, then we are not killed. Everything is okay. And we can just order some fix-ups, some people that come and fix our car, or if we can fix it by ourselves, if it's the tire or something, then we fix it. But the system is pretty much highly available. It tries to be as available as possible. Does not mean that we want the car to release an external fifth tire when there is a damage to the tire, because as you see, there is a cost to this. Fault tolerance comes with a huge cost. This is why part of the reason why building airplanes is so difficult. So fault tolerant is somewhat different from, a fault tolerant system is somewhat different from a highly available system, because in fault tolerant system, we are trying to reach as much as possible zero downtime, while in highly available system, we define that the system has this and this availability, 99.99% available, let's say, okay? But in fault tolerant system, when we say that the system is fault tolerant, we mean the system can continue to function properly, maybe not optimally. Maybe it would consume more fuel because now it's using only a single engine. But in general, the system will continue to function properly, although it has faults. When we have these faults, we try to isolate them. We try to isolate the fault to also, this would help the system to be fault tolerant, because when we isolate the fault, because if the engine blows up and this blows up the next engine and this blows up the wing and this blows up everything, we didn't isolate the faults. We want only the engine to blow up. We don't want it to blow up, but if it blows up, then we want to isolate the fault such that only the engine will blow up. So when we discuss fault tolerance and highly available system, and highly available means we want to minimize the downtime. And when we minimize the downtime in highly available systems, then we can give a number of what is the downtime that we can expect in a year. If it's 99% highly available, then we have 3.5 days a year of a highly available system, simply because 99% is dividing 365 days by 100 and then taking one of them, which is 3.65 days. When we say resilience, then it's almost the same as fault tolerance. Resilience means that when we have an issue, then the system is resilient to these issues. And the way we test for resiliency and for fault tolerance is by chaos engineering. We introduce regularly, repeatedly errors into the system, and we see that the overall system functions as we expect it to behave. This is versus game devs. In game devs, we focus on teams. We focus on the muscle memory of the teams, where they repeatedly, we increase the load, we cause some faults, and the teams need to overcome them. But But in chaos engineering, we repeatedly introduce errors, and we see that system without intervention from the teams usually, then we get the expected behavior. So we have highly available systems, we have fault-tolerant systems, we can have them both, of course. And when we use the general term that the system is reliable, then we mean that the system is highly available, it's correct, meaning the data that it's producing back to the user and back to the databases is correct, plus the system is mostly available, meaning we have it mostly available during the various time. We have small downtimes, so we have highly available system, and when we want close to zero downtime, then the system is fault tolerant.